Okay, welcome back. I hope that you have figured them out and just check the answer right now. But if not, if yet, it's okay. We can just do it together. So here I just set up the conservation of momentum collisions to be like the same because they doesn't change. This is the momentum initially of the mass A, right? This is the B. B stay at rest at first, that's why it just come to 0. And then this is the final momentum for A, and this is the final momentum of B. And the net momentum, the sum of the before equals to the one after the collisions. Okay, in this case, there's another extra information that really important, that MA equals to MB. So it means that MA, MB, MA, MB, all of them are the same. So can we simplify that? Yes, right? We can just like simplify it. Then what left is just VAI, right, on the other side. That equals to here, that will be the VAF, the final velocity of mass A, and plus with the VBF, right? Oh, I should have this one colors the same like the blue color to match with the B. Okay, so anyways, so from here we can see that the conservations of momentum turns out to be that the conservations of velocity just in this case, okay, when you got the mass to be the same, that's why they can cancel each other on both sides. So it means that if we add these two, this final velocity, they should equals to the initial one here, right? So let just copy them, and then we can keep the same direction. Okay, so now we have two vectors. How can we add them together? We can follow the vector additions, right? The method, either head to tail or the parallelogram. So let's try to do head to tail first. Here I will add just bring this one here, and then you can see that if we bring the tail of the second one to the head of the first one, oops, I need to bring them on together, then we just need to draw a vector from the tail of the first one to the head of the second one. Then that should be the resultant vector, the result of the vector addition. Okay, and then we know that they do not change, the velocity doesn't change before and after the collisions. So it means that this velocity initially of mass A, it should match with this one, this black one, right? They should match with each other. So from there, it's actually, if I bring this one out here, let me put the direction for the vector final for the B up. Then they should match each other like this. Okay, this is the relationship between these two vectors. So we should find a way, figure out a way to solve for the speed, the length of this one and of this one from what we know here. We know this one should be like 40 meter per second. Okay, if you go with the head to tail method, you got this kind of addition. But if you follow the parallelogram, what happened? So let's just try to do it as well. If we use the parallelogram here, let me just paste it, and then here, copy. But instead of having the head to the tail, we have the two tails together like this, okay? And then we will try to make a parallelogram out of these two vectors. So just more copying, right, like this, right? And then just another one, copy. I love GoodNotes for this function. It's just so convenient, you see? And then we also have like the final vector should go from the tail, right, towards the head. And you see, it's just exactly the same. So the two methods give the same result, and it makes sense. So now think about how can we find the magnitude, the length of this one and this one. And don't forget that we know this information as well, the angle. Here I have this one like minus 45 degrees because like in physics or like also in math, usually we count the direction counterclockwise as the positive. So if it go clockwise like this, then it should be like negative. It's just that it's just a conventional way. Okay, so give yourself some time to think how can we manipulate the relationship of this triangle or of this one with on this value angle to figure out the length of the two sides here by knowing this one side. And remember, two equations that we need to solve for two variable. Okay, so see you in the solution in the final video. Thank you. Good luck.